Hey, I'm Max.
I'm John.
I'm Raj.
I'm Nathan.
And this is our team, John Rocks. So this is our robot right here. It's called JohnBot. John's a little bit of a meme in our group. But basically what happens when our robot goes is, first thing first, when I turn on the competition space, it powers this motor back here, this back wheel. Right here, also in the CAD. And then that starts driving forward. Our device is 4 inches off the ground, which means it can clear the children with 2 inches to spare as well. Also, it can clear the missiles. It can just drive straight over the missiles, which it does for the middle missile. But basically what happens is it starts to drive forward, and then these mouse traps hit the first 2 missiles in the front, and just the natural trigger of the mousetrap triggers the mousetraps to fling the missiles out of the way and clear both those top 2. And then we have one mousetrap back here, also in the CAD back here. And that hits the last missile and clears that. The children are never touched because we're driving over them. And so we drive all the way up to the centerpiece, and then we have these 2 wheels in the front for rolling contact with the centerpiece. That lets us overestimate our motor time, so that it always, no matter what sort of track, extra bumps or more friction maybe, no matter what, if we overestimate it and have this rolling contact, no matter what track we're on, it always reaches the centerpiece. So once it reaches the centerpiece, we have this beacon here. Or I'm sorry, we have this long arm. So once this beacon is pressed, it fires this pneumatic actuator, which places our shrink ray. This top capsule places it in the top atmosphere. This bottom capsule places it in the second atmosphere, second from top. What that lets us do is we can see where other teams are loading their anti-shrink ray, and then we can plan accordingly and place our shrink ray in the team they're not when they're not in the zone they're not hitting ours in. And then the same thing for anti-shrink ray. It just hits the section to the right of us. And then we can see where they're loading their shrink ray, and then that'll place the anti-shrink ray in the same zone as they're placing their shrink ray. And then that brings us to the moon arm, which I'll let John talk about a little bit.
Okay, so here's what happened to our moon arm. So in the instruction, it said it's gonna be 25-inch on to the top of the dome, but actually it was like almost 30-inch. So we had to change our design from which was rigid. Now it's like folding at the back. You can see it here, like it's folding. So what it is like it's not in here, but like from at the first individual task, all 4 of us got the same design and we scored very well. And this is from that exactly same design. So now it reaches to the right in the center of the dome.
And we opted to use as little mechatronics as possible because a lot of them are unreliable, and things like the solenoids are really unreliable, so we opted to go for the pneumatic actuators so we could consistently get the shrink rays up into the right zones.
Right. So part of continuing the conversation of the mechatronics being unreliable, the results showed that we placed second in our studio with 452 points for our first competition. For our second competition, we only got 40 points and we placed 5th. And this was mainly because the mechatronics kit code was somewhat working, but we didn't have proper banana plug wiring, and the banana plugs gave out. So we weren't able to fire. We were able to switch out banana plugs with another team, and that's how we were able to get some points on the board. But this was a learning lesson for us.
So yeah, we're John Rocks, and we thank you for listening.